application of computer visions. So first of all, coming to the introduction part of computer vision, you can see here that computer vision is a subset of artificial intelligence and also the subset of machine learning, deep learning and convolutional neural networks. We all know that artificial intelligence is inspired by the human brain, which is based on neurons. Based on that principle, computer vision also works. So, this computer vision is a field of artificial intelligence which enables computers, machines to understand visual data. Visual data means we have image, we have videos. From those images and videos, we are detecting some objects or anything inside that video or objects. And this enables the computers to detect and identify those objects in the images and the videos. So it is automation of human visual systems so that computer can obtain high level of understanding of environment from digital images and videos. So whenever human beings look around, he or she sees something. For example, I'm seeing you guys are sitting and there are some desks and chairs and everything. So I'm seeing and I'm understanding the situation and the environment. So we want computers to do these kind of things. This is called computer vision. So AI helps computer think while computer vision helps them perceive and understand the environment. In this picture you can see that there are some people. Here is laptop, cup and chairs and so many objects are there. Being a human being, we can understand and we can say that these are the different objects placed there. So we want the computer also should learn from the environment, identify the objects and return us the output like this. So here this has been detected by the computer vision algorithm. For example, here persons making some boundary boxes for different objects. In advanced algorithms, computer vision algorithms provide the boundary box as well as the accuracy of that object as well. So we can identify different objects just like human being. Computer vision is interdisciplinary field. It is not confined with computers or only related to AI, but you can see here there are different fields which is associated with computer vision. For example, physics. In physics, first of all, the image acquisition, taking the image from the environment, we need some physics principles where the lens, through the lens, we take the images and store it somewhere. So physics is involved there. So if we are applying some cognitive principle on this image, we need biology. As I said before, that AI is inspired by human brain. So from human brain, we can see that there are different neurons in artificial intelligence architecture. In those neurons, computational analysis happens and some algorithm works in those neurons, and at the end, after processing it, it gives us some result. So here computer science, definitely we will be using some algorithm to classify or to detect those objects. Then mathematical and engineering parts also included in this. So visual perception, process of acquiring knowledge about environmental objects and events by extracting information from the light they emit or reflect. So how it works? In natural thing, for example, in our perspective, what, for example, this is an object, for example, tree. when light reflects on this object, the light enters to the lens of our eye through pupil, and it makes an image on the retina, and we can visualize it. And after visualizing it, our brain processes it. For example, if I am seeing this is a chair, I am seeing through my eyes, and it makes an image on my retina, and it goes to my brain, and my brain processes, yes, this is chair. So just like this, for example, if we talk about computers or machines or through lens of camera, so here is object, here is the lens of the camera. Through this, the object can be reflected here on the film of the camera or the scanner or whatever, depends upon the situation, and it forms the image there. After the visualization, so this is very important, visualization just to see. If you are only seeing, it doesn't make any sense, but there must be some cognitive activity must be there. That if I am seeing, but some people cannot recognize things. In dementia or in some other diseases, people can only see, but they cannot differentiate. So cognitive activity is also very important in human beings as well as in computers. In computers, AI algorithms does this job, and after that, after processing some activity, then we have some outputs. Just like this. So, what you can see in this image? Can you imagine? Can you see anything? You cannot identify what is in this picture, right? So there are some black and white patches. But when I draw this, you can see there is a dog, right? Now again see. Can you identify? You can identify, right? There is a dog. Yes. Previously when I showed you this image, you were blurred. You could not understand what is inside this image. But when I show you this one, and again I show you this, then you can, there is cognitive activity happening inside your mind, and you recognize that there is a dog. So this is also very important. In only vision is not important, not necessary, but vision plus cognitive behavior is also important. So vision versus computer vision. In this image, human eye see that there is a man and he is doing some painting. There is a trash bin and there is a light. If we talk about in terms of computer vision, the camera takes the image of this picture and it sends this image to the computer, and there will be some cognitive activity, and at the end, computer vision algorithm can identify there is a picture, man, trash, bulb and light. So, goal of computer vision. What actually we want? We want to transfer the daily tasks to computers and automate the tasks. This is the main objective of computer vision. And we want computers to solve problems automatically. And it bridges the gap between the image pixels and semantic meaning. So this is the main goal of computer vision. Here is the workflow of computer vision. First of all, we have image or video. We take image from video or image, then there will be some pre-processing. Maybe the image is not good, we need to enhance the image, there may be some distortion, we need to remove the noises from the image, and changing the colors. For example, if it is RGB image, we have to convert it into grayscale image or normalization and augmentation. There are different kind of pre-processing steps we have to follow. After that, once the image is ready, for example, we give some features from the image, then we will give it to the AI model, whatever be the model. It's depend upon you what kind of model you want to choose. For example, here they have shown GoogleNet, CNN, and YOLO, and some other architectures are well-known architectures are there you can use. After that, there will be training of your model, and then you can predict, you can classify, you can segment, and you can retrieve the information as well. So why it is important? So first of all, automation and efficiency. We want to automate our tasks, daily life tasks. For example, if you apply computer vision in manufacturing, you can identify the defects in the parts of the equipments or any products. You can automate it. You install a camera there, and it automatically detect the products which is defective. On the production line, we can identify which product is defective, which product is not defective. It also increase the efficiency. For example, if you hire a person and you assign him a task to identify those objects, then the efficiency will be low and the cost will be also high. So if you automate while using some computer vision algorithms, that will be better. Also enhance accuracy. Sometimes human error, because of human error, there may be the accuracy of that. For example, if we ask any person to identify the defects in the products, sometimes he feels sleepy, sometimes he feels lazy, so sometimes his concentration may be lost. So in that case, the accuracy will be low. But if you automate this with computer vision algorithms, then the accuracy will be high. Also improved safety. For example, if someone is seeing that object, for example, in manufacturing, there may be the risks, right? So if someone is doing that, if you automate this, then the safety will ensure, because computer vision algorithm and the equipments will do your task. Human intervention is very low, and the safety will be improved. Scalability. So scalability means you can improve and you can extend this to a large scale. For example, if there is one person, he can only observe in this room. If you automate this while installing different cameras at different places, the scalability can increase. And real-time decision making and security and surveillance. These are also very important, and through computer vision we can automate these things as well. So image processing. So first of all, do you have any idea what is image? Actually, image consists of grid-like patterns. These are called pixels. Okay, these are pixels, and image contains so many pixels. Actually, image is consisting of pixels, and these pixels have some values ranging from 0 to 2 to 5. These are actually the intensity values. This 0 shows black and this shows white. If the intensity at any pixel is low, it will be closer to 0, and if the intensity is high, then its value should be close to 2 to 5, and it is ranging from 0 to 2 to 5. So this is image. Image is consisting of pixels. So image processing is the process of transforming an image into a digital form and perform certain operations to get some useful information from it. Here you can see there is an image. original image, there is blur, gray, flip, sharpening. These are different forms of this image. While applying different operations on this image, we can blur this image, we can convert this RGB image into grayscale, we can flip this image, and we can sharpen this image, we can zoom this image, we can also augment this image. So there are different operations we can perform on an image. So how machine sees images? As I told you that machines works on digits, zeros and ones. This is the basic concept of computers. So machines interpret the image. For example, here is an image, and this is converted into digits from 0 to 2 to 5 maybe, and depends upon the intensity, the values are changed. For example, these are the pixels and these are the pixel values of this image. And image has 3 channels: red, green and blue. So the 3 channels are there, and every channel has different values, you can see. So there are different types of images. You can see here I have shown 4 types of images: binary image, grayscale image, RGB color image and RGBA image. So binary image, what is binary image? Images that have only 2 unique values. Either it has 0 value or it has 1 value. This is called binary image. For example, here is an image. This is color image. If we convert it into binary image, then it will be either black or white. So the value here is 1 and the value here is 0. Then grayscale image. So grayscale image are 8-bit images are composed of 256 unique colors, where a pixel intensity of 0 represents the black color and pixel intensity of 2 to 5 represents the white color, as I told you before. This is grayscale. For example, this is RGB image and grayscale image. RGB image. RGB images we are used to modern world are RGB are color images which are 16-bit. That was 8-bit and this is 16-bit images to computers. There is 65,536 different colors are possible for each pixels. So you can see for 3 channels RGB, and this is the histogram of each channel. So RGBA image. So in this image we talk about the opacity. Opacity means that, for example, if this is the term of physics, I guess you already know about the opacity of an object. So if this value range from 0% to 100%, here you can say see 100%, 70% and 50%. So if the object is too much opaque, for example, in terms of physics, if the object is opaque, we cannot see through that object. If it is transparent, then we can see through that image as well. So basic steps involved in digital image processing. First of all, coming to the image acquisition. So first of all, we take the image through camera lens, and for example, in case of medical images, we have scanners. Using scanners, we scan the images, for example, tissue images at different scales. For example, different magnification level of the images, 40x, 5x, 10x, 20x. Then image enhancement. So sometimes we take image, but the quality of image is not so good. So we need to apply some operation on the image to enhance the quality of the image. So we remove the noise from those images and other artifacts from the image. And after that, image restoration. This involves removing degradation from an image such as blurring, noise and distortion. And image segmentation. So in image segmentation, for example, we have different kind of objects in an image. So we segment out each object in the image. This is called image segmentation. We will talk about image segmentation in further slides. So wavelet and multi-resolution processing. It is foundation for representing images in various degrees of resolution. So every image has different kind of resolutions. So this is handled by this wavelet and multi-resolution processing. And image synthesis and compression. So in image synthesis, we generate new images from the previous images. For example, from original image, we use different kind of algorithm. For example, gain. This is one of the popular algorithm used for generating synthetic data. And compressing existing images to reduce storage and transmission requirement. So sometimes we need to compress the image and only focusing on the silent features of the image and discarding the not important those images, those features which are not very important, we can discard. And morphological image processing, extracting image components that are useful in representation and description of vision shapes such as boundaries, extraction, thinning, and equality. These are different techniques which we use for morphological image processing. Image representation and description. So, representing an image in a way that can be analyzed and manipulated by a computer and describing the features of an image in a compact and meaningful way. So, actually, what image processing is? What is the difference between image processing and computer vision? In image processing, we just give an image and the output will be an image. And the output image will be a refined image. And that kind of image which we actually want after performing different kind of operation. For example, if you want to blur an image, for example, if this is original image, right? So if we want to blur this image, we apply different kind of operations on this. Gaussian blurring or changing operation, different kind of operations we can apply. And the output is an image, image process. But in computer vision, if you give an image, then there will be some other tasks, for example, object detection, feature extraction, or prediction, or classification. So image analysis. In image analysis, this is the last stage of image processing. We can perform different operations, for example, detecting patterns. If there is, for example, some ROI drawing of, for example, tissue images, detecting the tumors, or only extracting the region of interest from the object, from the image. This is image analysis. So, difference between image processing and computers. As I mentioned before, that process an image to generate another image, right? Input is an image and output is an image. Process in computer vision, process an image to produce desired results in real time. The desired objects may be objective may be classification, maybe object detection, or some other task. Depends upon your scenario. And in image processing, we use different kind of methods. For example, hidden Markov method, component analysis, and filtering. In computer vision, we use machine learning techniques, CNN, YOLO, SAM, some kind of different kind of algorithms. An example of some image processing applications are rescaling, digital zoom, correcting, illumination, changing tones. An example of computer vision is face detection, handwriting recognition, and object detection. So, where image processing used? Here I have mentioned few examples. There are a lot of other examples as well. For example, machine vision and robot vision. It can be used in robots. For example, if you want your robot to perform in an environment, for example, Zia is working on reinforcement learning. He is using some robotic simulation. In there, this can be used in robots. And color processing. If you want to apply some color processing, for example, blurring or changing the grayscale to RGB, RGB to grayscale, or HSP. So different color processing, for different color processing you can use. And for pattern recognition. Pattern recognition, for example, there must be some patterns of any object. So to find the pattern recognition, you can also use image processing. Video processing, transmission and encoding, the medical field. It is very popular in medical field as well. We apply different kind of operations, image processing. For example, segmenting the images, enhancing the quality of images, and finding the ROI of the images, changing the scale of the images, changing the magnification of the images we can use, and also image sharpening, restoring, and facial recognition. So, image loading and displaying. Here I have shown a few examples. For example, first of all, CV. OpenCV is used for processing the images, and Matplot is used for displaying the objects. Here is the code. For example, here it is reading this image and show here. This is another example. There are different ways you can display the images. So coming to object detection. Object detection is a critical capability of computer vision that identifies and locates objects within an image or video. You can see that here is an image. There is a dog, there is a bicycle and a car. While using this computer vision technique, you can identify different objects in the video or in images. So unlike image classification, object detection not only classifies the object in an image but also identifies their location within the image by drawing a bounding box around each object. So these bounding box have some information. For example, it has x, y coordinates of this object. So you can identify where the object is located. It not only identifies the object but also tells the location of the object as well. So object detection methods. There are different methods you can apply for object detection. Here you can see RCNN, region with convolutional neural networks, and fast RCNN, faster RCNN, mask RCNN, and YOLO. These are the older techniques which people used to use, but YOLO is the one which is very popular and trending these days. There are different versions of YOLO, starting from YOLO 1 to now it reaches YOLO 10. So I recommend you to use this YOLO technique for object detection, and it's easy as well. I guess most of the students had applied this technique as well. I guess in last semester, Ibad had applied, and also some other students applied. Mohsin also applied. There are different versions of YOLO. For the newcomers, for the first semester and second semester students, you can go for this YOLO object detection technique. So, YOLO adopts a revolutionary single-stage object detection approach. This is developed by Joseph Redman and continued by Ultralytics. And the main advantage of YOLO include speed, end-to-end training, and generalization. So what actually YOLO is? You only look once. Means just you give the image to the model and the model detects what is inside the object image and identify the objects in the image. And it's end-to-end training. For example, you give the image and it gives the output. So here I have shown the YOLO history. It started in 2015 and now they have released YOLO version 10 in 2024. So YOLO can perform different tasks. For example, it can classify different objects. For example, person, tripod, and safety vest. Also, it can detect and also showing the accuracy. Here you can see that the accuracy of this person is 92 and this object is 88. And it also segments. For example, it is segmenting different objects. For example, this object, and this object with different colors. Segment out different objects. And also it can use for traffic tracking. It can, for example, how many cars are coming from a single point, or how many what kind of vehicles are going through that way. And also you can use for pose estimation. Semantic segmentation, here you can see these have same color, persons have same color, and it is differentiating from the background and this object. So this is semantic segmentation. And if you talk about instance segmentation, it segments every object in the image. For example, this is woman, it has different color. This is man, it has different color. This is another person, it has different color, and this is sky and it has different color. Likewise, background has different color. So this is image segmentation. Image segmentation methods. There are different methods which we use for image segmentation. One of the popular one is thresholding segmentation. So it involves setting a threshold value, then classify each pixels in an image as foreground or background. So if I show here, you can see that this is an image. Here we have used thresholding. For example, binary image for binary image 0 and 1. 0 shows the background and 1 shows the foreground. That is why in white color, that is fish. So this is thresholding method. And another one is edge-based segmentation. Edge-based segmentation focuses on detecting edges or boundaries within an image, and it spots sudden changes in intensity, color, or texture. So, for example, in autonomous vehicles or robots, it is very important. For example, a robot is going, or a vehicle is moving on the autonomous vehicle is moving on the road. Then they use edge-based segmentation. There may be abrupt change in the intensity of the image. For example, the intensity of this pathway is different, and the intensity of this disk is different. So they use edge-based segmentation in such kind of scenarios where the abrupt change of intensity is important. So region-based segmentation. Region-based segmentation involves grouping pixels into meaningful regions. It is very popular in medical imaging. For example, we have an image. This is a tissue. For example, this is a tumor. So, in region-based segmentation, there may be some segmented. For example, this region which shows the tumor has this different intensity, and it it shows that the intensity of this area is different from this area, and there may be some region. For example, this region shows the tumor region has some different pixel values. And also clustering based segmentation. Clustering based segmentation groups pixels into clusters based on their similarity. It also a little bit similar to this one, region based segmentation, but a little bit different based on the similarity of the features. But in region based segmentation, it also consider the texture and intensity and the color of the images. And instance segmentation, as I shown in the previous image, in instance segmentation, I guess it is better if I show from here. Yeah, here. Instance segmentation means segment each object in the image. This person, this person, this person, this person. So this is called instance segmentation. So image segmentation, some code implementation. Here I have written a function which segments the image. We are taking the image and setting some threshold value, and we know that image is consisting of rows and columns, means pixels. We are storing here, and we are also interested in finding the area of the image, so we have assigned a value here. And here in this function we are displaying the size, maximum value, minimum value like this. And this is another example. Here you can see that the area is this one, size of the image is this one, and maximum and minimum values are shown here. So color segmentation. Here in this image we have two colors, for example red, yellow and green color. So with this code we can segment out different colors. Here RGB, different examples we have shown here, and concat all the, for example R. This shows the red channel, this shows the green channel, and this shows the blue channel. So color segmentation. So if we want to segment out, for example, this red color from others, so we have set some threshold value. Based on this threshold value, you can segment out different colors. You can change the value, and you can change. You can get different results. So edge detection. So we have taken the same image, and we want to find the edges of this image. For example, it has been shown in blue color. First of all, we are reading the image, and it will check whether it has been loaded successfully or not. Then we are converting the image into BGR to grayscale, because when you read in OpenCV, the image is read in GBR, and we are converting into grayscale. When you convert the image into grayscale, you can perform operations easily. It simplifies your operations. Otherwise, it becomes complicated, and computationally, when you are dealing with huge images, then you face some problem. So mostly people work in grayscale. Here then we are applying some Gaussian blurring and also caning, and we are displaying the image like this. Segment anything model. This is very popular model, recently published by Meta, Facebook, and it is very popular. And first version was released in April 2023, and now in July 29th, 2024, they have released the second version of segment anything model. Here it can segment out different objects, for example fish, and here some trees. It can segment out different objects with different colors. And according to Meta, SAM2 is 6x more accurate than original same model at image segmentation task. So this is one of the very popular algorithms for segmentation these days. Then coming to the feature extraction. Feature extraction is a critical step in image processing and computer vision. So if you want to apply some AI model, for example, deep learning or machine learning, feature extraction and feature selection is very important. Based on these features, the accuracy and the performance of model increases or decreases. If your features are not good, then your model may be underfit or overfit. It doesn't give accurate accuracy when it goes to real-time situation. So feature extraction is very important. Here you can see there is an image, for example, input, and we apply some feature extraction. For feature extraction, there are different methods we will discuss, and at the end we have some output. Types of image features. So an image has different kind of features. Low level features, mid level features, and high level features. Deep semantic features are high level features, which we can extract while using some CNN based architectures, for example autoencoders, VGG 16, 19, whatever. And from the image it extracts very deep features, and it may be in hundreds and thousands. And we have texture features. Texture features focuses on the shapes and texture of an image. And other features, we have edges, corners, and blobs, etc. So this is high level features, and these two are low. The low level features are mid level features. I have mentioned some of them here. You can explore more. So why feature extraction is important? So dimensionality reduction. For example, if you are using any neural network architecture or deep neural network architecture, you extract so many features, hundreds and thousands of features are there. So sometimes all those features are not so relevant. So dimensionality reduction is very important. If you utilize dimensionality reduction, then it only focuses on those features which is more relevant, and intrinsic features can extract while using this dimensionality reduction. It helps increase the performance of your model. In other words, the accuracy will high, and it also help reduce noise. While using some denoising autoencoders, you can reduce the noise from your data, and also enhance performance definitely. And feature extraction methods. These are some handcrafted features, texture features. Some examples of are GLCM, SIFT, SURF, or LVP, and deep semantic features. For deep semantic features, we can use ResNet, VGG, or any other neural network, and autoencoder, etc. So implementation. Here I have shown just an example for classification of image, and it can be extend further while adding some other, for example, grade game or explainability to this one. Visualization, for visualization we can extend it. So first of all we have image, then we have extract the features. As we have discussed, we have different features, deep semantic features, and handcrafted features are low features, right? So here we are extracting both the features, deep semantic features and texture features. Then we are going to concatenate both these features, and we'll give these features to the AI model, and it will classify different stages of cancer, for example, early stage and advanced stage. So here in this screenshot, you can see we have export all the necessary libraries. For example, NumPy, Matplotlib for displaying the images, and CV2, OpenCV, CMON, Pandas, all the necessary libraries we have accepted, and then we have two containers, train images and train labels, and after that we are reading the images from our system and storing them in those two matrices. Here we are normalizing the images with this code, because normalization is very important, because there are different scales, pixel scales. So to bring them into a uniform level, we need to normalize the image so that it may not overfit. Here is the feature extraction. This is a function which applies for extracting the handcraft features. For example, we have GLCM features, energy, homogeneity, dissimilarity, and others. Here it has two variables. For example, this shows the distance between different pixels, and this shows the angle of those pixels. So we have accepted 15 handcraft features, and here you can see. So for deep semantic features, here we have used VGG19. While using this architecture, we can extract the deep semantic features. You can use any other model as well, maybe ResNet, MobileNet, Inception. Here you can see that we have accepted. After concatenation, just like traditional machine learning, we have split into train and test, and we have applied some classifier here, and that's all. You can extend by adding some grade cam to this one. And so application of computer vision. Here I have mentioned some examples. For example, computer vision in healthcare for cancer detection, COVID-19 diagnosis. We also applied this, for example, for the diagnosis of COVID-19, and we had 4 classes, different classes, and we were detecting COVID-19 opacity or some other classes. I can show. So tumor detection, also movement analysis, mask detection, tank detection, pet activity detection, farm automation, crop monitoring, flower detection, plant disease detection. These are different applications of computer visions you can see and you can apply. Thank you.